as the ramp, or the rail as we call it in this experiment, slides along the floor, the force required to slide it remains about the same. So as the ramp coasts along the floor, it doesn't matter how fast or how slow it's going, there's a frictional force between the floor and the ramp has to exert a force in that direction to overcome the frictional force, which is pointing back in this direction. The frictional force tends to resist the motion, so the ramp has to exert a force that counters that frictional force in order to keep moving. And of course, that force, the frictional force, tends to slow the ramp down. To see that that frictional force remains constant, we could do another experiment. We're not actually going to do this experiment, but I could take a ramp and allow the rail to slide down the ramp. Okay, you probably can't see that very well. Let's get it here. Okay, the rail accelerates down the ramp. By doing an experiment similar to the one we did when we allowed the cart to run different distances down the ramp, we could verify that this acceleration is constant. It doesn't matter how far or how fast the thing goes, the acceleration seems to be the same. And if we change the slope, we'll get a different acceleration, of course, but it will still be pretty much a uniform acceleration, which shows us that the frictional force is very nearly constant. So what happens, excuse the noise, what happens when we pull this thing back and release it, better get the other end there, when we pull this thing back and release it, we do work to pull it back. We do work against the stretch of the rubber band. That stores up what we're going to call energy. When we release the rail, we get that energy back. Now what happens is the rubber band is going to release the rail at this point. We pull it back, and then on releasing it'll go up to this point, and then the rubber band is going to let loose. You can see the rubber band has gone slack. The rail is going to have its maximum velocity at that instant. Then it's going to use up the energy it has as a consequence of that velocity as it coasts to a stop. It uses up that energy by doing work, exerting a force through a distance against friction, which resists it. So we want to talk about the energy concept in relation to this situation, and we want to analyze what happens to the energy in the three phases. While the rubber band is accelerating the rail, while we pull the rubber band back, then while the rubber band accelerates the rail, then while the rail coasts along the floor against the relatively constant force of friction.